Okay, this is 9 questions from chapter 9, your last 9-question review that you'll have for this chapter for your test. So the 9 questions are fairly simple, I think. The first question says all students 14 years or older may attempt, expressed as an inequality both numerically and graphically. So A will be ages, and your age must be 14 years or older, which means your age must be equal to or greater than the number 14. So numerically, that's how we would express it. And graphically, if I put 14 here, then any age that is greater than or equal to 14 will be a closed boundary point. Oh, that should be a 15, not a 5. And any age that's 14 years or greater graphically would look like that. Question number 2 says express in words and as an inequality. So the first thing, if this was a question in your test, because it's an open boundary, that means it has to be boundary. It's either this sign or this sign, because it cannot be this or this, because that would be a closed boundary point. Oh well, I just lost it. So it's an open boundary point, which means it's going to be less than or equal to. And since 1.2 negatives, it's all values that are greater than, negative 1.2. So as a written inequality, that it would be all values greater than negative 1.2. So on your test, you get 1 point for writing it as that sentence, and then you get another point for writing it as a written inequality numerically. Yeah. Next question, we have all values. This is a tricky one. So we have all values greater than, oh, that's not a marker, greater than 8. So this is not including 8, so just greater than 8. All values that are greater than 8, but less than or equal to 12. There we go. Now, even though it doesn't say how to do this, I'm going to write it down anyway. So I'm going to put all values in the middle. So all values greater than 8 would look like that as an inequality. All values greater than 8. And if I read it this way, all values less than or equal to 12 would look like that. So expressed as an inequality, starting at my variable and reading it this way, this says, take my highlighter, this says all values greater than 8. And this part right here says less than or equal to 12. So writing it as a double inequality, if I put my all numbers in the middle, I could translate that to a numerical inequality as that. Next question says x minus 3.5 has a value of or greater than or equal to 4. So the first thing I need to do is isolate my variable. So I'm going to add 3.5 to both sides. I'm going to get all values greater than or equal to 7.5. And once I have that, I'm going to place 7.5 here. And you could do either 7.6 or 8 or whatever you want to do. It doesn't really matter. But this is fine. Closed boundary point. And all values greater than or equal to 7.5 would be this way on my number line. Next question. Negative 10 has a value that's less than or equal to negative 2 times all numbers plus 5. Or negative 2 multiplied by a set of numbers plus 5 will have a greater value than or equal to negative 10. So when I isolate the variable here, I'm going to subtract 5 from both sides. Give me negative 15 is less than or equal to negative 2x. My next step will be divide both sides by the coefficient. And you must remember that if you divide or multiply both sides by a negative number, you must flip your inequality sign to the opposite, and you would have 7.5. So your answer says all values less than or equal to 7.5. So 7.5 will go here. This time we'll go 8 and 7 here. And all values less than or equal to 7.5, close boundary point, and your number line will go this way. So any number that goes on that infinite set of values will make this true. So if I took any value, for example, the number 0 will fit on that red number line that goes to infinity. If I substituted 0 for x here, I would have negative 10 is less than or equal to negative 2 times 0 plus 5, or negative 10 is less than or equal to 5. And is that true? That is true, because 5 is greater than or equal to 10. So any value I substitute in for x, as long as its value is 7.5 or less, will maintain that inequality. Your next question, I'm going to bring it over here because it's a little bit complicated, but not too bad. Two ways to solve it. You can either multiply both sides by 8 or subtract 3/4 from both sides. I'm going to subtract 3/4 from both sides because I don't think it's going to be very difficult. We'll see how things go. I'm going to have x plus 1 over 2. It's greater than or equal to, common denominator will be 1/8. Multiply both sides by 2. I'm going to get x plus 1 is greater than or equal to 2/8. When I multiply 1/8 by 2, I get 2/8. Or, in lowest terms, 1/4. And finally, I'm going to subtract 1 from both sides, and all values that are greater than. What's 1/4 take away 1? Well, some of us can do that in their head and get negative 3/4. But if you can't, think about 1 as being 1 over 1. And 1/4 take away 4/4 will be negative 3/4. So any value that's greater than or equal to negative 3/4. So I'm going to make this negative 3/4. I'll make this one negative 2/4. And I'll make this one negative 1 or negative 4/4. I suppose I could make this instead of negative 2/4. I could make it negative 1/2. And those would be all the negative quarter increments. All values that are greater than or equal to, so close boundary point, all values greater than or equal to negative 3/4 would mean any value that goes on that number line to infinity would be true. And your last question with solving inequalities. If you have variables on both sides, we were taught the easiest way to get rid of it is to subtract it from one side, giving you negative 5 is less than x plus 4. Some people think you had to flip your signs there. Well, you weren't dividing or multiplying by negative 2. You're subtracting 2x from both sides, so you do not have to flip your sign. Subtract 4 from both sides, and all values greater than negative 9 is your solution. So if I put negative 9 here and negative 10 here and negative 8 here, all values greater than negative 9 is an open boundary point, and all values greater than negative 9 is your solution. Toby is saving for buying a car. He currently has $450 saved, and he works at Tim Hortons making $12.25 an hour. What is the minimum number of hours he must work until he has enough money to buy the $8,650 car? So the first thing I need to do is his savings must be greater than or equal to the price of the car. So before I start really putting in expressions, I want to get my head around what I want to do. So I'm going to physically write his savings must be greater than or equal to the price of the car. That's my first step. The second step is to figure out how much he's going to save. So the first thing is I know he has $450, so I'm going to treat that as a constant. And if x equals the number of hours he works, then if I multiply the number of hours he works by 12.25, this here will represent the money he makes at Tim Hortons. This money will represent the money he already has saved. So those two together must be greater than or equal to 8,650. So once I have that, I'm going to get rid of the constant by subtracting 450 from both sides. which means $8,200. No, 8,000. Yeah, $200. Divide both sides by the coefficient. I'm going to take my calculator. 8,200 divided by 12.25 is 669. So x is going to be greater than 669 point something. So since he can't work part hours, he has to work greater than 669 point something. So on my number line, therefore, he must work at least 670 hours to have enough money. Because he can't work 669 hours because that won't be enough, right? He has to work more than that. So since there are no part hours, if I think about it this way, and we'll just round down, so 669 point, what was it again from the calculator? 0.4, roughly. And so we have to round that to 669 hours, sorry. Oh, poopy darn. 669 hours, 670 hours, 668 hours. He has to work greater than or equal to this amount of hours, 670. No, you don't need that part. But you have to be able to interpret it as the number of hours he has to work has to be greater than 669 point something. And since there is no point something, the next hour he must work is 670. Okay. And your last story problem says John makes a weekly salary of $12 per hour plus 15% commission on sales, and Jane makes $20 per hour. How much sales must John make in order to make his job or to make more money than Jane that week? So we're going to start with John, and we're going to create an expression. John makes $12 per hour plus 15% on sales. Now, if I make X, oh shoot, oh poopy darn. There, I just corrected my question. So they have both work a 40-hour week. How much must John make in sales to make more money? So X is going to be the amount of sales, because we're looking for that in our question, amount of sales. And since John is making $12 per hour, then in a 40-hour week, John will make 40 times $12, and Jane will make 20 times 40 hours. So he will make $480, and she will make $800. Okay? So those are going to be our constants in our inequality. So 15% of sales is going to be represented by 15%, which is 0.15, because 15% is 15 over 100, and 15 over 100 as a decimal is 15 hundredths. So 15% of the total sales means I multiply it by X, which is the amount of sales, plus John makes $480 for the week. This value must be greater than the amount that Jane makes, which is $800. So let's put this in word form again. John's money must be greater than Jane. And since John makes 15% of the commission plus an additional $480 in hourly wages, eventually that has to be greater than Jane's sales or Jane's salary of $800. So I'm going to subtract 480 from both sides. I'm getting 0.15x is greater than 320. Divide both sides by 0.15. And x must be greater than 320 divided by 0.15, $2,133.33. So, therefore, if John sells more than $2,133.33, he will make more than Jane.